Hey guys, Vincent here, and in this video I wanted to address a question I got recently from a viewer regarding what were my favorite classes as a chemical engineer at UC Berkeley. And I have a list of classes that I want to make sure that I can at least mention once in this video. And I don't like calling classes, because another part of the question was what were my least favorite classes. I would like to rephrase this to be most challenging classes I have faced as a chemical engineer, just so that I'm not rude. And yeah, and so um, and this is in uh, no specific order. So like I'm not saying my number one thing is my favorite class or whatever, but I'll just start rattling off some of the things that I really enjoyed. Anyway, so the first class that I took at UC Berkeley that I really began to like a lot was, ironically, I think one of the harder classes, which is the chemical reactor design class. And this was where they really began to take the training wheels off in terms of the kind of problem sets that you would have. And it became a lot more about being creative, because I really enjoy trying to come up with the creative solutions to problems. And obviously you're going to have to first understand why people have done things a certain way in a particular process. So like there's a way that we've made ammonia for over 100 years, and you really should understand why people have made the decisions that they've made to have this process in place. But it isn't until you get into the higher level classes as a chemical engineer that you can now say, like, well, what happens if I up the pressure or decrease the temperature or use a bigger reactor volume, or throw in some more whatever spice catalyst. Anyway, so yeah, that class was called CBE 142, and I wouldn't quote that because they may change the numbers, but it was chemical reactor design, and the textbook is right here. Actually, I keep it on my desk because I love it so much, and I keep saying this is Folger, but it's actually Fogler. So yeah, and I just absolutely love everything in that book. So yeah, that was the first class that I took that I really began to enjoy being a chemical engineer, and that wasn't until my junior year that you can take that class, because you need to take first 140 and 141, which are the intro upper div chemi class, and then thermo. And yeah, so that's class number one. Class number two, which not really sticking well to a chronological sequence here, but this was one of the last classes I took as a senior. This was the lab class, CBE 154, and that's where you were, again, training wheels were taken off, and you were told to come up with a experimental design. And I think it's really supposed to be preparing you for graduate school at that point. But like you do an experiment, you're on a team, you have a team lead that changes each experiment that you would do throughout the semester, and eventually you get to a place where you are presenting in front of a panel, or one professor, and they are asking you, why did you do that? What do you think these results really mean? How can you improve your design? And for me, it was definitely a lot of fun that I enjoyed a lot. So lab was really cool, and you know, I think if I could say something to people who are having a hard time with, your first 1 or 2 or 3 years as a chemical engineer, is that even though it's really hard, and you're putting in a lot of sacrifice to learn the basics, once you get into like the higher upper div classes, such as the labs and the design classes, it's where everything kind of comes together. And even though you're going to forget things here and there, you'll see how it ties in, and then you can have like stories behind why is your distillation column 15 trays, and why is your feed at the third tray from the bottom, and these types of things. So uh, as much as it's just going to be boring math when you're learning it as a sophomore or a freshman, it really kind of begins to make a lot more sense when you can visualize it, see it, work with it as a senior. So um, yeah, and then another class that I wanted to mention was my process design class, and this was the very last class that I took as a senior. So this was literally the last class I took, and then I was done. But yeah, this is process design. So this is, notice the theme here. I really like design and being creative. So with process design, we were just given this problem statement, and you're told to use Aspen to come up with some kind of chemical process, size heat exchangers, size reactors, determine what kind of reactor you're going to use in order to maximize the production of some component of interest, and create this as safely and efficiently as possible. And you also get into a little bit of economics, where you're figuring out how much is this plant going to cost to run, what are the costs of your feed, how much can you expect to sell your product for, what kind of revenue will you have. And so it's kind of a little businessy type stuff, and it's almost kind of coming up with a complete project, so that if you wanted to take your idea to a board of directors or investors, you could do that. And you boil things down to a very simple: how much is this going to cost, how much can I expect to get out of it, when can I expect to get this much out of it, and figure out if it's something that's actually profitable to do in the long run. So that was a lot of fun, because I really love economics too, even though I don't have too many videos on that. I admire the field a lot. And so the other class that I will say that isn't really a required class, that I enjoyed a lot too and kept me sane when I was an undergrad, was the undergraduate research that is optional, but you also have to fight and get into a lab somewhere, which I know that can seem very daunting and anxiety provoking, but believe it or not, it's actually doable as long as you just keep at it. And yeah, I can talk more about how to get into the research labs later, but basically what I really liked about doing research at Berkeley was that uh, it really gave me a chance to work with a postdoc and my fellow undergrads. And even though I'm not really that social person, I got to get to know people a lot better. And, all of us being at UC Berkeley and some of us being chemical engineers, it was really an opportunity for us to kind of get to know each other and see how other people were thinking about problems that we all had and what solutions we could come up with as a team. And it was a really great experience to see how on a team you can be greater than the sum of its parts, if that makes sense. So other people are going to come in, and it's great if you can communicate well and be open to feedback and be able to think critically about other people's designs, and try to understand how they're thinking about a particular solution or a problem. And yeah, that was a great class. And then as a final remark in this video, I think I would talk about one of my most challenging classes, and that was quantum mechanics. And that is a required class that UC Berkeley made their chemical engineers do, that really was hard for me. And the teachers are great, the students are great. The material itself, though, I don't think I can say is intuitive. It is not intuitive. You'll hear probably the greatest physicists of all time, Feynman, say that no one understands quantum mechanics. And what I don't know how much graphic detail I should go into in this video, but the thing with quantum mechanics is that I walked in to the final feeling like I knew no more about quantum mechanics than I did walking into day one of class on the first day of the semester. Like I literally, I don't know, I can't follow anything because none of it made sense. And if I could give any advice to people who are about to take quantum mechanics or considering to take quantum mechanics, especially if you're an engineer like me who doesn't really I don't know what kind of skill set you need to have to understand this. I would say being good at math is probably the number one thing, and specifically linear algebra, but even more specifically statistics are your best friends in quantum mechanics because that is the gist of the field. If you can understand what's going on in terms of how a wave distribution, how a statistical probability distribution is evolving in response to something, you will be eons ahead of where I was when I started taking that class. So, um, yeah, that was very challenging. And then I guess as an added bonus, because why not? My other very, very challenging class was thermodynamics, and that was because the material can get very almost philosophical at times in terms of like when you look and when you really begin to think about the laws of thermodynamics and why these things, like what do they mean and how do you apply them, and all these numbers and state variables, and um, yeah, it is definitely, that was one of my harder classes too that I took as an undergrad. But the important thing to make note of is that even though, so great way to kind of tie things back together here is that like even though quantum mechanics or thermodynamics seems like it's just work and you don't really see why people should care about any of this, it does really help uh, make things more clear and appreciate what's going on behind the scenes when you are running your Aspen program in process design, because Aspen is literally just running a bunch of thermodynamics equations to figure out when this thing reaches 70% of the way to equilibrium, this is the kind of conditions we expect to have inside of this batch reactor. And so that is kind of the, in a nutshell, what to expect out of thermo, and uh, a little bit of a taste for what is chemical engineering. And so I'm going to wrap things up for this video without making it too long. I hope this is interesting, and let me know if you guys have any questions, and thank you for watching.